new design. They're not so new, actually. So, and you have talked for some of these with Mary in one of the previous lectures when talking about cohort studies. So I'll talk about sort of alternative to the classical case control design. So nested case control studies, case cohort studies, and case crossover studies. And I'll do that in half an hour, which will be a test for both you and me. So this is a description of the big EPIC cohort, the nutrition cohort in Europe, about 500,000 people, about 400,000 with blood also, and starting follow-up mid-90s and keeping follow-up until now. And in one of the analyses that were done, they wanted to evaluate DNA adducts. DNA adducts is a biomarker. We'll talk a bit more about it in the exposome lecture, where you have a contact of some kind of a chemical on the DNA. There's nothing produced, there's no mutation produced, but it's a covalent binding of a chemical with the DNA. But this means that something has reached the DNA and could, in principle, when the cell multiplies, produce a mutation. So it's interesting biomarker. And basically what you're measuring is these lines here, this diagonal lines. And they wanted to look at DNA adducts that are, type of adducts that are produced from polyaromatic hydrocarbons, PAHs, and lung cancer. So they got non-smokers. They had 115 lung cancer incident cases, non-smokers, and they wanted to see whether they had samples from earlier, from the beginning, from the mid-90s, so before the disease, and they want to see whether this associated with lung cancer. So they wanted to get non-smokers. You know, I arbitrarily assumed that about 200 would be non-smokers, not never smokers, non-smokers. So they had 115 lung cancer cases. So they had 199,885 non-lung cancer participants. And they wanted to do this quite complex assay measuring DNA adducts. So they would do it here to the 115, and then they would do it to this other 199,885 and compare. And say it would come out like that, the marginals. You know, 115 cases and 199,000 controls, and doing a laborious test to everybody, you know, not efficient. Not efficient at all. You really don't need so many controls. You need all your cases, sure, but why would you do a very costly test with 199,000 controls? It's not efficient design. So what is a more efficient design is to do a nested case control study. Rather than doing a cohort analysis, analyze on everybody and then see how it's distributed, get your cases and get, say, double number of controls sampled from the cohort and do your analysis, and you'll get exactly the same results. So nested case control studies are just more efficient in many situations than doing a proper cohort analysis. And we know that because you increase your number of controls per case, and you know, you have 1 per 1, you get a second, that's a pretty good increase in study power. But then as you start increasing the number of controls per case, you don't gain a lot of study power. And then think of going from 10 controls per case to, you know, 199,000. You gain nothing. And if it costs a lot, you know, you cannot do it. It doesn't make sense. So that's why we do, rather than doing this thing, evaluate everybody, we just do a nested case control study. We evaluate all the cases and controls who are selected from the cohort, and we do a case control design. Mary went a bit through that, but I want to go again through that. Say we have a follow-up study of 11 subjects, and the black dots are the subjects who fail. So in the nested case control study, what you would do, you would get the person who failed, who got the disease, and you would select randomly a control from this risk set. And the risk set could be defined by age, sex, country, or whatever. And from all the people who at this point in time were alive, didn't have the disease, and had the same age and sex, you would randomly get a control. And then when the next case occurred, you will do the same. And notice that this participant could have been a control here and then would have become a case later. And this is not a problem. If you think of it of our studies, when you do a case control study, get cases and controls, you are not a fortune teller to know who will become later a case. At this point in time, somebody's a case, somebody's a control. Some of your controls will in the future become cases, but you don't know that. And you still keep them as controls. It's the same thing what we're doing here. We still, if we had selected this person as a control for the first case, we will still keep this person as a control, and then this person would also enter as a case. Obviously, this person would not contribute to the risk set here, because that was a case, out. And you would do this thing and you would get all your controls. So for a nested case control study, you select all your cases, and then you do some kind of time matching to the cases using incidence density sampling, and a control can be selected more than once, and a control can become a case. And then you have a set of controls for a set of cases. And so these controls, with some exception, but this is the rule, are used only for one outcome, which, if you think of it, if you're doing something pretty complex in terms of a biomarker, that's not the most efficient thing you can do. But we'll come back to that. And when we select the controls, we can match for confounders, say length of follow-up, age, sex, etc. And we can use, we use conditional logistic regression, and we condition on the risk set. So we have each analysis by risk set. And because we have sampled, this is something also that Neil mentioned in his lecture, because we have sampled from person years, our odds ratio would be an estimate of the hazard ratio or of the rate ratio. So we calculate odds ratio because it's a nested case control study, but this would have been equivalent as if we had done a totally prospective cohort design and analysis. So why would we do? The main reason is efficiency, just to reduce labor and cost of data collection. So you do all these fancy analyses only for the subject chosen for the nested study. And because it's a cohort study, you have samples that were collected a long time ago, which is good. So you don't have the situation that we have in normal case control studies where you have the disease, you get a sample at that time, and you don't know that whether what you find, if you do a biomarker, was before or after the disease. So here we have samples before the disease. That's the advantage. And obviously, cohort studies last a long time and new hypotheses originate. So you want to have the possibility to test new hypotheses that you hadn't done. We do all sorts of analysis initially, new hypotheses, you want to test more. And a nested case control design is clearly a very, very efficient way of doing it. The concerns with the nested case controls design is that outside epidemiologists, nobody understands person years and this type of sampling. So sometimes it's difficult to explain how you got your controls, but that's a minor thing. The controls are not representative of the cohort population because they are selected on the basis of the cases. And then the control series, precisely because they're selected for a case, for a specific disease, you cannot use them for other things. So you do all this effort, all this analysis, and they are selected from a risk set. It's not easy to use them for another disease. So that's one of the reasons why now there's growing interest in, now I'm meaning 15 years ago, interest in case cohort analysis. So I'm going to go into the case cohort analysis, unless there are any questions for the nested case control design. That is really, frankly speaking, very, very similar to the classical case control design, but we have physically a cohort from where we select the people. Are there any specific questions here for this design? Or shall we move to the case cohort? Okay, I hear nothing, so I'll move to the case cohort design then. This is what we're doing in a nested case control study. So we have the entire base of the cohort. We get some cases of, say, Parkinson, and we get controls for disease A, and then somebody else wants to look at a low back pain and get some other controls. And that's what I was saying. For disease B, we get a set of controls. For disease A, we get another set of controls. Not the most efficient way. It's good, but it's not the most efficient way. And then somebody else comes with another disease, lung cancer, and gets another set of controls. So the idea of the case cohort design is to make it a bit more efficient. And it is more efficient. It is a bit more tricky to analyze. And so that's why people are not doing case cohort studies as much. It's a bit more tricky, not very, in the statistical analysis, I mean, tricky. So the basis of the case cohort design is that you get a random subcohort from the entire cohort. So you get, and you can do a stratified sampling also. So you get this subcohort. And this is the basis of your case cohort design. And then you select the diseases that you want to do, say Parkinson, low back pain, lung cancer. And as is expected, some of the people that have the disease, would have been included in your subcohort. So this is just saying what we have just done. We selected a single subcohort and we added all the cases or more that occur in the cohort outside the subcohort. This is important. The subcohort is what it is, but the cases come from the whole cohort. So we want to increase study power. If you think of it, what we are doing is like calculating risks and a risk ratio. When we're talking about how we calculate risks and risk ratios, we have the base population, we follow the people, and we see how many develop the disease or die. And the risk is just the number of people who get the disease divided by the number of people in the beginning without the disease. That's what we're doing here. We are getting people with disease, and rather than getting the whole cohort, we're getting a random sample. So think of it like that. So controls are selected from those at risk at the beginning of the follow-up from the entire source populations, and controls are selected from the denominators for a risk ratio analysis. So this is what we have. And the important thing is that we are not getting only the diseases from the subcohort, but we're getting these additional diseases, cases. And this is what adds complexity. Because if you think of it, by adding to this random subcohort more cases, we are biasing our sample. It is not any more random. And that's where there is a trick in the analysis where you have to take into account of different weighing factors. But that's all of it. So we have one subcohort that we use for all the different diseases. Pretty efficient. You don't have to get separate control groups for each disease. And this subcohort is just randomly selected from everybody. And as evident, if you have too much overlap between the disease and the subcohort, then you may have some problems. I mean, they're soluble statistically. But for many situations, diseases are rare and you don't have any overlap or partial overlap. The subcohort is a random or stratified random sample from the cohort. And if we were analyzing just the subcohort on its own, we would just do a Cox regression, some kind of partial likelihood approach. But we don't want to do that. We don't want to analyze only the subcohort. We want to enrich the analysis with the diseases from the whole cohort to have more power. We want to add these cases. So this is what is the tricky thing in the analysis, that we have the case cohort design and we include all the cases in the whole cohort, and we have then this control subpopulation. And then in this, it's a standard cohort analysis, what we're doing, but you have, because we have introduced some kind of a bias in a way, it's not only a random sample, but we have introduced additional cases. You just have to take this into account. There are standard packages in R, Stata, that you use some kind of weighing to arrange for this oversampling of cases. It's not so complicated. It's not a straightforward, unconditional logistic regression, but it's not so complicated either. And it's much more efficient. What is an issue that we have? Because we're doing that a lot in the biomarker studies. An issue that we have, let's go back to the scheme, is that you may have done initially disease A with a subcohort and then say, oh, I want to do another disease, and you get disease C with a subcohort. Again, the same subcohort. And then after 2 years, we want to do disease B. If you are dealing with biomarkers, this could be an issue for some biomarkers because you're analyzing in your lab the samples in different times. For disease A, it's okay, you analyze the subcohort and disease A at the same time, but then you want to do disease B later, 2 years later. So you get another set of samples. So you may have batch effects, storage effects, and freeze-thaw cycles effects. And these are serious issues because not all the chemicals, proteins, or whatever you want to analyze remain stable. And then you may have batch effects, obviously, and there are solutions to that. But you have to think of it. So there are some issues with the biomarker-based studies when you do case cohort studies at different time periods. And so the summary, the case cohort design, cases are defined as those participants in the cohort who develop the disease of interest. Controls are identified before the cases develop and are randomly chosen from all cohort participants, regardless of whether they have the disease or not. And baseline data are collected early in the study because it's a cohort study. The advantages is that you only need to select one reference group, very efficient, and you can evaluate multiple outcomes. And like the nested case control studies, you do analysis with equal power as if you would have done the whole cohort, basically. The differences are, they're very similar to the nested case control studies. The main differences is the way in which controls are chosen. And the main advantage of the case cohort design over the nested case control design is that you have the same control group. The main disadvantage of the case cohort design is that it requires a bit more complicated statistical analysis. And under some circumstances, and depending on the biomarkers you want to use, it could be less efficient. But so you have to know the both designs, and we are not using as much case cohort studies. They are very, very interesting designs to use. So in the last few minutes, sorry, we are a bit late, but I just want to go very quickly through the case crossover studies because they're extremely interesting for people who are doing injury research in occupational settings. So the case crossover design are just case-only studies. Comparisons of exposures during cases in an index interval and exposures during a reference interval. So what are we doing? We have an event, say an accident, and we look what happened before the accident, the index interval. Was there ventilation? Were they using gloves? Were they taking other protective measures? And we compare with some kind of reference interval. what happened same time, but a week ago or 2 days before. Very clever design. So you get the index event, you compare what happened, what triggered the event, and then through registers, you also evaluate what happened a few days ago. You randomly select a reference interval. So you compare the case to himself or herself. Really clever design. And for trying to identify immediate associations using protective measures and an accident, say, this is an extremely clever design that we have not used enough in occupational epidemiology. That's as far as I will go with this. It's pretty quick presentation of case crossover, but we are sort of short in time. And just to say that the index, the time interval could be a single day, an hour, or any other time interval, depending on your hypotheses. And this has been used a lot for things triggering, so doing jogging and getting an acute myocardial infarction, or drug intake and skin rash, or say red wine and migraine, or mobile phones and car accidents, extremely important studies, or protection measures and occupational injuries. And if you have this type of question for what triggers something, this is really extremely interesting design. So I had as an example the story of the mobile phones, extremely important studies to regulate the use of mobile phones in cars. And I think I will stop here and get some questions. And I'm sorry that we went a bit late here.
Actually, we have time, Manolis. You have until 3:30.
Is it 3:30? I thought it was 3:15 that I had.
But we can also have discussion too, however you like.
No, I prefer to have some discussion. Actually, I went a bit quick on some because I thought we had until 3:15, so I have until 3:30. But let's have some discussion.